In this problem, we want to find the oblique asymptote of a given rational function. We're given the rational function g of x equals 2x squared plus 3x minus 5 all over x plus 2. What we want to first note is that the degree of the numerator, which is 2, is 1 larger than the degree of the denominator, which is 1. Whenever this happens, I'll obtain an oblique asymptote. The way we're going to find an oblique asymptote is by classic long division. So remember that this x plus 2 in the long division process goes on the outside. And on the inside, I put the numerator 2x squared plus 3x minus 5. And I'm going to perform long division. This shouldn't take too much time. We want to find an expression when multiplied by x that gives us 2x squared. Well, one expression that will do that will be just 2x. So I'm going to put a 2x right here. 2x times x is 2x squared. 2x times 2 is positive 4x. And then, of course, I can subtract this row. 2x squared minus 2x squared is 0. 3x minus 4x, that gives me a minus x. And now I can bring down the minus 5. I can then multiply this x times a minus 1 to give me this minus x here. That's minus x. And then do the same thing here. 2 times minus 1, that's a minus 2. And then negate this row as well. This becomes a positive x, so minus x plus x, of course, is 0. Minus 5 plus 2 is 3. So what I've done is I've rewritten this expression. I've said that this is equal to the quotient 2x minus 1 plus 3, this should be a plus, 3 over x plus 2. Now let's look at this for just one moment. G of x is just rewritten in this format, 2x minus 1 plus 3 over x plus 2. What this has allowed us to do is see more clearly what's happening as x gets arbitrarily large. Notice that as x gets arbitrarily large, 3 over x plus 2 approaches 0. So I'll write that down. As x goes to plus or minus infinity, we see that 3 over x plus 2 approaches 0. What that leaves us with is this piece. In other words, what this is saying is that since this piece goes to 0, this is the important piece of what's going on. Therefore, our oblique asymptote, as it's called, must be just this piece here. So our oblique asymptote is what's left over. We can write it as a function y equals 2x minus 1. So if you were to graph this, you'd see that this line 2x minus 1 is in fact the oblique asymptote for this function g of x. In this example, we found the oblique asymptote of a rational function.